Hello, gang. In this chapter, we're going to talk all about video. Video is one of those areas in computing that you're going to find things are happening very quickly in and quite often. So a lot of video cards that come out are going to be newer than even the stuff that we talk about here. And I'm honestly not sure what all you're going to see on the exam about video cards. I'm going to just talk about what is popular right now and hope that that will give you a good background for some of the types of questions you may see on the test. So we're going to talk about video cards and what they are. We're going to talk about PCI, AGP, and PCI Express cards. Almost everything you're going to find is going to be PCI Express now. We're going to talk about how video card drivers work. We'll talk about the different types of displays, mainly CRTs, LCDs, and data projectors. We'll talk about how to install a video card and the connector types, VGA, DVI, and HDMI. And we're going to talk about what resolution and refresh rates are, and then how to troubleshoot video and displays. So, video cards are exactly what they sound like. That is the device in the machine that allows the computer to display things on the screen for you to see. Most motherboards have got some kind of onboard video now, especially any what I'll call off-the-shelf machines. Almost any Dell you buy is going to have some sort of video card built into it. These are generally low quality, but on some better motherboards you can find high-end video cards. And interestingly enough, on some upper-end motherboards, you won't find video at all. And the reason for that is they assume that if you're going to buy like a gaming video, a gaming motherboard, that you're going to add your own video to it anyway. So you're just going to turn off any kind of onboard they put on it. So after onboard ones, the first editions were PCI. And these are legacy because PCI is slower now than what newer video cards can offer. AGP came out as the answer to PCI, and it was faster than PCI, but you're only going to see that on old machines, Pentium 2 to Pentium 4. And now all modern machines are going to have PCI Express slots on them. And those are what you put your video cards in. Those are generally connected to the north bridge of the machine, so they are much faster. Video cards, just like your motherboard, are going to have RAM. And the reason they have this is so that data can be directly written to and from the video RAM faster than the RAM that's actually in the computer. You'll generally find that the RAM that's on video cards is faster. For example, video cards were the first place to see DDR5 memory. And now DDR5 is slowly making its way into computers as well. And the reason for this is that video display is very memory intensive. Without getting into the details of how it actually works, your graphics card has to use these complex math calculations in order to display things on the screen. And that takes a lot of memory and a lot of processing. That's why a lot of video cards have their own processor as well, called a GPU, or a graphics processing unit. So video RAM serves as your buffer between the data that's going to be displayed and the RAM in the computer, or the CPU. So again, a GPU is a graphics processing unit. It is a CPU for graphics cards. They're generally found on a graphics card. Most modern graphics cards are also going to have fans and heat sinks and such on the card itself, because it can overheat just like the CPU in your computer can. Again, passive and active heat cooling. Remember, passive is no moving parts. That's the heat sink. Active is a fan. And again, just like with your CPU fans, you need to keep them clean of dust and make sure there's airflow around it. If the only add-in card in your computer, for example, is the graphics card, you may want to put it down at the bottom so there's plenty of room for air to flow around it. So there are many different types of displays. The oldest type of display that we'll discuss is the CRT monitors. These are the big, heavy monitors, you know, that you've seen that are kind of deep. They are being replaced, but you still find a few here and there, and they're being replaced with LCDs, or liquid crystal displays, and in some cases LEDs, which is an LCD with an LED light source. So LCD monitors are displayed. They've got a couple of features. The quality or the dot pitch is one. They say catching up to CRT. I'm going to say that it's way surpassed that now. It is not uncommon to find LCDs that have super great resolutions, or LED monitors as well. And most of them have both analog and digital inputs. Analog being VGA, your standard input that's been around for a while, or DVI, which is digital video input interfaces. And we've got a slide coming up that will talk about what those connectors look like. You also see some plasma displays, and those are used in TVs that are also used for monitors. A lot of your large TVs will have connections that can be used for both. It's not uncommon now that we're getting to where inputs are common, that you can project your computer display onto any of these larger TVs and things. Also, data projectors are an option, and they can be LCD or DLP, which is digital light projection. Here we got an example of how an LCD works. And basically you have 3 different colors that are combined using mirrors to make the image on a projector. The main thing that happens with projectors is that the bulb goes out and will need to be replaced. And based on the type of projector that you have, that'll be a little bit different with each. So putting a video card in a computer is fairly straightforward. Some of the things that you need to configure in the BIOS, if it's an old machine, the AGP settings. Other things you may have to set are the graphics aperture, and generally you're going to use the default settings for that. If your display has onboard and you're adding one, you either need to turn off the onboard display or set which one's going to be the primary display card. Putting the card in the machine, you need to turn the system off. Make sure that you, ESD protect yourself. Touch the back of that power supply while it's still grounded. Remove the old card if necessary. Then you'll need to boot up and install the drivers for the video card. And this is an important thing to know. The initial setup is usually done plug and play, but to get advanced features out of your card, you most likely need to install a driver from the manufacturer. The reason that video cards all use the standard VGA drivers is that with operating systems, it would be near impossible to install something on the computer if you didn't have a picture on the computer at all to be able to install. Most newer video cards, for example, they will drive at what's called just standard VGA resolution at like 800 by 600 or 1024 by 768. So that you can see how to move around to download and install the driver. But in order to use the GPU and the memory and all of the extra features and to drive 2 monitors or 3 monitors based on what you've got, you need to install those drivers. You're also going to want to keep your drivers updated pretty regularly. As new games and things come out, they will write different video drivers that do different things for those games. So that's something that you should keep updated pretty regularly. Here's just an example again. They're showing you how to install an AGP video card. And if you're dealing with AGP, you'll have this little card retention mechanism. You have to open it to remove it. You're not going to see AGP cards unless you're dealing with some old equipment. Almost everything you deal with now is going to be PCI Express. So there are a couple of types of connectors that modern computers will use to display video. And those 3 are VGA, DVI, and HDMI. VGA is analog. That is the standard connector we've had forever. It's the 15-pin connector. DVI is digital video input, and there are 2 types of that, a DVI-I and a DVI-D. DVI-I handles analog and digital connections. Most modern video cards are going to be DVI-I, and the reason for that is that you can put a little adapter on the back of your video card that runs from DVI into VGA so that you can plug a VGA monitor in. DVI-D, on the other hand, is digital only. And finally, a third type that is used a lot in the video area is HDMI, and HDMI stands for High Definition Multimedia Interface. This is what your HD TVs use, and the differences in DVI and HDMI are that DVI does not carry audio, HDMI carries audio. There's a trick here, though, for you to know. They're the exact same specification, just with a different cable. If you want to display your computer on a TV, and your TV has HDMI, but your computer only has DVI, you can buy a DVI to HDMI cable, and you will get video out from your computer to your TV, but you'll need a separate cable for audio. Other types that are old, you might find a computer with component RGB, which is red, green, and blue wires. S-Video, which was one that of the first types of video captures, and then finally composite, which composite is just an audio cable and a left and right audio cable and then a single video cable. Component, S-Video, and composite are all lower resolutions than will be provided by either VGA, DVI, or HDMI. Here's an example of what the cables look like to give you an idea. This is just the standard DB15 VGA cable and the VGA port on the back of the computer. This is a DVI cable. And if you'll notice here, the DVI port here supports digital and analog. And the way you can tell is if you look at the bottom, the cross, if it's a complete cross like that, then both types of cables can be plugged in. It'll run analog and digital. If you look at the cable here, they showed a cable that is DVI digital only. And if you notice, instead of a cross, it's got a piece here that's only going to be one way. The way they're holding the cable, this piece is vertical. If this were a DVI both, it would have that where it's cross, and if it were just an analog signal, that would be horizontal. And here they're showing why those have become so popular. If you've got a port that's both on your video card, you can plug one of these DVI to VGA adapters in and then run a VGA cable to your monitor. That way you can run analog if your monitor only supports that. So in installing a monitor, you need to match up the appropriate cable, DVI or VGA, based on what type of input your monitor will take and your video card can produce. I would suggest DVI if that's possible because it's digital. You're just going to get a cleaner picture. You'll need to set the refresh rate. You want to set the refresh rate as high as both will allow, but you want to make sure that your computer can handle it. If you're dealing with DVI, it's not as bad, but if you're dealing with VGA, be careful not to damage those pins. Even though that cable doesn't look like it'll plug in upside down, if you force it, it will, and if you force it, you'll bend those pins. Then you can have all kinds of problems. Go to the display adapters to set your settings, and then go to the advanced to make further adjustments. Like if you have two monitors, that's where you'll go to set where the second monitor is. And most likely, you're going to need to install a driver. So displays are given in resolutions, and that is done by the horizontal width times the vertical width. For example, if I say 1024 by 768, that is a standard type called XGA. Each of the different types of displays has a different name, and I don't think you'll see that on your exam, but be aware that there are different names for each of them. If you do a quick search on Wikipedia, you can find the names of all of them. Then we also have color quality, which is measured in bits. 16-bit color, for example, provides 65,386 colors. 32-bit provides 4.3 billion colors. That's the amazing thing about video displays now. We're getting into displays that do so many colors you can't even see them all. Refresh rate shows how fast the image on the screen is refreshed. And they say 70 hertz is best on a CRT, but since LCD screens don't flicker, 60 hertz is adequate. Here they're just showing the display properties. This is in XP, but it's going to look the same in Vista 7, 8, or 8.1. They're showing that you have 2 monitors here, and you don't have to set the resolution the same on both. The way you would tell it that your second monitor is on the left instead of the right would be to click on the 2 and drag it over to the other side. So some of the advanced adjustments that you have, you can display, you can change the text size, you can adjust the refresh rate, you can use hardware acceleration to adjust the mouse and pointer settings, and you can use a full screen 3D to lighten the screen for 3D games. Here they're showing the screen on 7. Notice this one's got 3 monitors. This is a whole lot like the screen you just saw on XP. So if you have to do some troubleshooting, one of the things that you can do usually is adjust the on-screen display settings. And things that you can adjust there are the horizontal size and centering and the vertical size and centering. You can also change the brightness and the contrast. Generally, if you're not getting a good display, maybe it's too far up off the screen, you can make these little tweaks and it'll get the screen back where it needs to be. So here they're showing an example of some of the things that happen. Barrel distortion is where the corners are rounded and your video is not taking up the whole screen. Pincushion is just the exact opposite of that. And then a parallelogram distortion is where the top and bottom screens are not properly and the image is skewed a little bit. A lot of modern monitors also have an auto adjustment. You can push that auto adjustment and they will adjust the settings for you. So there are some things you can do to troubleshoot. With a CRT, one thing you can do is called degaussing, and that is where you actually will, if your monitor doesn't have it built in, you have to do it with a magnet. You have to be very careful, but at most of the last sets of CRTs made have auto degaussing features. There's a button on it you'll push, and that button will make a magnet go through, and it will change the distortion around the edges where it looks a lot better. If you're getting flickering, you may have a bad or a loose cable. If there are lines in your display, that can be caused by electrical noise. And the way you solve that is by putting a magnet on the wire that runs into the computer from the monitor, or by moving whatever wires you've got back there that are next to it that are causing some problems. If you don't have a picture on an LCD screen, the first thing you should do is check to make sure the proper source is selected. Most monitors now have VGA and DVI, and some have HDMI. But if you're on the wrong source, you may not get a picture at all. If you're dealing with a projector and you see colored dots, that can indicate a need to clean the panels. A lot of LCD projectors now will also display a message that says clean filter when that's needed. And if the picture is misaligned on an LCD, sometimes changing the resolution settings will correct the problem. So displays create heat just like everything else. Try to not block the ventilation holes. Use anti-static cleaners to clean the screens and other surfaces. Do not spray the cleaners directly onto the screen. Instead, you should spray the cleaner onto a cloth and then onto the rub your cloth over your screen to clean it. Use the thumb screws at the end of the cable connectors. That's an important one because those cables, even if you don't mess with them, will fall off. And inevitably somebody will call you to come work on their computer and you'll get there to find out the cable was just unplugged. When you open your computer, I've said this in previous chapters, but make a habit of taking a can of air and cleaning the thing out. Take it outside and just, hose it down with your air. When you do that, make sure you blow the dust off the video card too. Most video cards are going to have a fan on them and you want that fan to run. And again, allow as much space around that video card as you possibly can. So, Chapter 7, we talked about displays, we talked about troubleshooting the cards, and some preventative maintenance. Thanks for watching.